Okay, I'm Beynon from Active Silicon, a UK-based company. We're one of the founder members of the CoaXPress consortium, which is for the new CoaXPress standard to connect cameras to frame grabbers. It's a very high-end standard to compete way above the levels that CameraLink can currently do. I'm on the GIA booth at the International Standards area at Stuttgart show, and we have demonstrations here of some of the technical work that's been going on in the standardization process. The first demo here is the standard. Currently the only commercially available chipset is from one supplier, Ecologic. So there's been, while this chipset works extremely well, there's been some industry concern that it is the only chipset available. So the GIA have produced an alternatives demonstration here using chipsets from National Semiconductor plus their own analog circuitry. So the demonstration here has a transmitter board, 20 meters of cable and a receiver board, and they're showing on the bit error rate tester here that you have a good eye pattern and a 0-bit error rate at the same time using this alternative circuit. So while it may not be the ideal circuit for a manufacturer to use, it proves that there's a perfectly viable solution there for them to work with. So that's demo one. Demo two, over on the left here, is the trigger performance. Another area that some people think that CoaXPress isn't fast enough, but it's not the case, is for the triggers. That CoaXPress has a fixed latency for trigger, but a very low jitter on trigger. So the demonstration we have here is there's an active silicon frame grabber in the PC at the back. We have an oscilloscope hooked onto that frame grabber that shows the trigger where we produce it within the frame grabber. And then in the camera, there's an Adimec camera here that receives that trigger down the CoaXPress. And we have a scope probe on the top of the camera, also on a test point, that shows the result. The top trace in blue shows the trigger from the frame grabber. The trace at the bottom in purple is a trigger from the camera. And when they zoom in, you will see there's a 3.66 microsecond delay between the two. If I go to the second scope setup, there is a jitter performance here that's about 10 nanoseconds jitter. So even though we have a fixed latency on the link, we achieve extremely low jitter times. This 10 nanoseconds can be halved with a faster camera than we're running with here. So that is the quick summary of these two presentations for GIA at Stuttgart. Thank you.